Hello and welcome to another video. Today we will continue learning about vectors. You can rewrite any vector as a combination of the magnitude and the cosine of an angle. When we talk about this angle, we are talking about the angle of direction. Please keep that in mind. So remember, the angle of direction starts on the positive x-axis and then it goes towards the left side or counterclockwise. So if you remember, the component form is a comma b. So a is going to be equal to the magnitude of the vector times the cosine of the angle of direction, and then b is going to be equal to the magnitude times the sine of the angle of direction. Keep that in mind because we can use this equation to figure out what the direction of the vector is. I'm going to show you two different ways to find the angle of direction. The first one is going to be with basic trig. So if we were to plot the vector 2, 6, remember your tail will be at the origin, and then your head will be at 2, 6. So we can see that we can create a right triangle with a base of 2 and a height of 6. And then, like I said, the angle of direction goes from the positive x-axis to the vector. So we can use the basic trigonometry to find what the angle would be. So we have our opposite, which is 6, and we have our adjacent, which is 2. So the tangent of the angle is equal to 6 divided by 2. So to find the angle, all we have to do is find the inverse tangent of 6 over 2. Once we do that, I'm going to redo this. I'm going to go to approximation. So it's approximately 71.57 degrees. So this one's pretty easy because you are in quadrant 1. You don't have to worry about adding things or subtracting like you would in any other quadrant, which is what we're going to do in the next example. Okay, so we're going to start by plotting it. So in this case, we're going to go 4 units to the left and 8 units down, creating our vector in quadrant 3. So it's going to be 4 units to the left and then 8 units down, and then our theta will be in there. Don't forget, we're looking for the angle of direction, so starting at the positive x-axis, going counterclockwise up until this angle. So we can do it two different ways. We can do 180 plus theta, or we can use the 270. But if you use the 270, you would have to do some extra work and find this red theta at the bottom and subtract that from it. So I'm going to do tangent of theta equals my opposite, which is 8, divided by my adjacent, which is 4. So inverse tangent of 8 over 4. Once I do that, I get around 63.43 degrees. Again, since I'm in quadrant 3, I'm going to add the 180 plus 63.43, which will give me my answer of 243.43. Again, it makes sense because it should be between 180 and 270. So now I'm going to show you a different way that you can find direction. This time we will use the equation a comma b equals magnitude of the vector times the cosine of the angle of direction, comma, magnitude of the vector times the sine of the angle of direction. I like using the cosine because the way that it's going to work is if you're in the top two quadrants, once you solve for this equation, A equals magnitude of u cosine theta, it will give you the actual answer. If you're in the bottom two quadrants, all you have to do is subtract the answer from here, from 360, and that will give you the answer. So again, top two quadrants will give you the answer. Automatically, bottom two quadrants, you have to take that number and subtract from 360. I will show you that if you plot the vector, it will kind of help you figure out if the answer that you have is the correct one or if it's the other one. So for example, in this one, negative 3, comma negative 5, 0, 90, 180, 270. So I know that my answer has to be greater than 180, but less than 270 in order for it to work. So when I do this, when I solve this equation, I know I have to subtract from 360 because I'm in the bottom two quadrants. So on this one, negative 3 is equal to A. I need to find the magnitude. So square root of A squared plus B squared, like we talked about in the last video. So it'll be the square root of negative 3 quantity squared plus negative 5 quantity squared. It'll be the square root of 9 plus 25, which is the square root of 34. So now I know that the magnitude of this vector is the square root of 34. I can plug that into my equation times the cosine of theta. Again, I'm solving for theta, or the angle of direction, so I'm going to divide both sides by the square root of 34. So now to find my actual theta, which again is not going to be my final answer, I have to do the inverse cosine of negative 3 over the square root of 34. Inverse cosine of negative 3 divided by the square root of 34. Once I do that, I get my answer to be about 120.96. 120.96 degrees. Again, it doesn't make sense for this angle to be 120 degrees, 0.96. So that's actually going to be this one in the bottom going in the negative direction. Just the way that it works. So again, all I'll have to do is do my trick. So I'm in the bottom two quadrants, so 360 minus 120.96, and I get my answer to be around 239.04. 239.04 degrees. And again, that one does make sense because that number is greater than 180 but less than 270. Let's start plotting the next example just to figure out if we're in the top two quadrants or the bottom two quadrants. So in this case, it's going to be negative 4, comma, positive 8. So it'll be somewhere up here in quadrant 2. Again, my answer should be between 90 and 180. And since I'm in the top two quadrants, when I solve for the equation, it should give me my answer. So in this case, it will be negative 4 equals the magnitude of u times the cosine of theta. So again, I'm going to find the magnitude of this vector. So that will be the square root of negative 4 quantity squared plus 8 squared. And then I'm just going to do it on my calculator. 4 squared. Again, the negative is going to disappear after I plug it in. And then add 8 quantity squared. So this will be the square root of 80. I am not going to simplify it because I'm going to be working with it. So negative 4 equals the square root of 80 times the cosine of theta. Divide both sides by the square root of 80. And then all I have to do is find the inverse cosine of negative 4 over the square root of 80. Of negative 4 over the square root of 80. and I get 116.56 degrees. Again, it makes sense because it should be greater than 90 but less than 180. You can use whichever method you want. If you do use the first one, keep in mind that you have to do some extra math to figure out if you're adding or subtracting a certain number. If you're using the second method, all you have to worry about is, am I in the top two quadrants? Then my answer is good. Or am I in the bottom two quadrants where I have to subtract that data from 360? Again, if you plot it, it should give you a good idea of what the numbers should be between what two numbers. Thank you for watching. Hopefully you learned something. Don't forget to like the video and subscribe if you haven't. Have a good day.